Hello everyone. In this video I'm going to talk about our cluster analysis case study. So we have some data of stores in its latitude and longitude data of our stores and the total demand of our store. These are the two, the latitude and the longitude are our dimensions, and our total demand is our measures. So anything which can be aggregated is measures. So our total demand can be aggregated or can be summed. So it is a measure, and anything that cannot be aggregated is a dimension. So our latitude and longitude of each store is a dimension. Alright. So we have this data, and we have only these three columns of data. Actually, I have generated this, which I'm going to talk about. So we have about 402 rows of 400 399 basically. These values I also have added at the end, which I'm going to talk about. So initially we had only three rows, that we had destination latitude, longitude, and our total demand. Okay, then I have also imported this. Actually, I have copy pasted it here. Coming back to here, we have destination latitude, longitude, and cluster number. So this cluster number, basically we have basically what we have done, we have imported this cluster number from the Python, and in our Python we did k-means clustering. In that, we had taken the number of k-means to be 5. Yeah, from 0 to 4. So basically we have taken 5 clusters. So our algorithm has generated some clusters, and according to that we have named them named those clusters from 0 to 4. So this is the data we have imported from our Python, the cluster number. Okay, yeah. So now what we will do, we will select these three columns, then we will go to insert pivot table, and once you do that, click OK. After that, inserting pivot table, we will generate and also the cluster number you have to take, select all until here. Then you create a pivot table. So in this pivot table you have the row labels, which is basically the cluster we are having. So if I click here, we have put it our cluster number into our rows, and the summation of values, it is come automatically. Let me see if I can increase or decrease the size. No, I cannot. So in values, wait, yeah, now it is little bit better. We have taken the sum of weighted latitude, weighted longitude, sum of demand, and cluster number. So before that, let's talk about what is weighted longitude and latitude. The weighted latitude is basically the total demand multiplied by the latitude, and weighted longitude is total demand multiplied by the longitude. So we are getting weighted latitude and longitude like this. So it basically get us the demand wise latitude and the demand wise longitude. So it is our weighted latitude and longitude. That is. Then similarly we have copied it all over until down. So similarly we have calculated every for it every rows, and after that we have done the pivot table, and in which we have inserted the sum of the weighted latitudes, the sum of the weighted longitudes, the total sum of the total demand, which is this sum, and the count of the cluster number. So in the 0th cluster we have 123 items. In the first cluster we have 8 items, second 174, similarly down. Now we can see that uh, then we have copied it. We copied it and pasted as values here. Then we have calculated our percentage contribution. So what is our percentage contribution is our the sum of our total demand, which is this, or we have also calculated here as well, sum of total, this basically, this divided by this item. So in this case, the percentage contribution we are getting of that of demand. So demand wise, the this is more significant. Like this is the greatest percentage we are having, 26.41, so it is more significant. And no, the greatest is 53.7, so this one is the most significant. Then this, then this. Then we are seeing that less than 1%, we have two clusters that we are having, which is less than 1%. So we can just simply ignore this. We just simply delete these values, okay, and we copy paste it here. So the zeroth cluster, second cluster, and third cluster are more prominent, on which we will perform our cluster analysis. So I have also calculated the weighted latitude and the weighted longitude. The weighted latitude I have calculated by dividing the sum of weighted latitude by the total demand. So initially what we did, we multiply the latitude to the demand. Now we are dividing it by demand. So it is giving us a location of the latitude and longitude, which we are getting dependent on the uh, cluster weighted cluster. So that would be the place where we will be opening our store. So basically what we are doing here is we are opening warehouses, such that uh, wherever the demand is the greatest. So we will open our warehouses where the demand is the greatest, and such that, let's say, we in our warehouse we sell product to Amazon. Let's say we keep a logistic of Amazon. So we have a lot of, in our warehouse we have a lot of products, and all these products are to be delivered to the respective uh, homes. So what we in the industry, we want that our time of travel is minimized. So our the travel time should be minimized, and the distance should be minimized. So in that case, this analysis is very much helpful, because it will give us the minimum distance, and with distance also it is demand wise. It is also giving us through demand. Okay. So similarly, we have calculated the latitude longitude for the all the clusters 0 to 4, and we have kept the zeroth cluster, second cluster, and third cluster we have kept. Then what we have done, we go back to sheet 2. Then we have copied that here, and we have named the cluster to be 9. So what we have done, we just copy this, not this, these three values, and go down and paste below all the data we are having. This all the data that we are having, we just go down, copy this, and paste it down. Okay. Then after that, now let's go up. We have the destination latitude, longitude, and the total demand, and also the total demand which we need to copy. So let's go back, and demand, these are the demands cluster. So we also copy this and place it down in our demand. These are the same values. Okay, and this is the cluster. So now we can just not consider this, because this is the weighted latitude and longitude. So as of now we are not considering this. Now what we will do, we will import this data over this entire data to our Tableau. So after importing, let me show you. After importing the data source, let me show you. We have the cluster, we also have the weighted latitude and longitude, but we are not using that. Okay, so you can see that this data is here and this data is here and this data is also here. Okay, now what we did, we actually had the destination latitude and longitude in the measures. We drag and drop it up above, and also we had the cluster numbers in also in the measure. So basically we just drag and drop it into the dimensions. Now otherwise, if it is not, it is in the measures, then it will calculate the aggregate of it, which we don't want. Then what we did, we just selected this. Let me just show you in another sheet. First we select this and we just drag it here. So now I am getting all the stores that we are having in the latitude and the longitude. So now it is showing all the stores in the entire world map. Now let's group them through the cluster. I'm dragging the cluster to the color. Okay, so now my all the clusters are grouped by the color. So this is cluster, this cluster, this cluster, and this is another cluster, and this is another cluster. Now, and I need that total, my total demand to be varied in sizes. So I will go there and just drop it in the size. Now I can just shift and drag, mouse click, and just move it around like this. I am seeing the size is very small, so let's increase the size, edit sizes, and just increase the size to this much. Okay, apply. Okay, now it is looking a bit better, and you can see that the cluster number 9, which we have demand wise weighted demand, it is showing the largest. So this the red region is where our warehouse we will open our warehouses, and this is one cluster, and the distance between these clusters is the minimum, the base depending on the demand. So this is a demand wise cluster, and this is another demand wise cluster, and this is another demand wise cluster which we are getting. Okay, so this is the analysis that we have done in the Tableau, and after that let's go back to our Excel. In our Excel, we have calculated the weighted latitude and longitude. Now let's go to the sheet 3. Let's go up. Now, what all the latitude and longitude which we had here, these two, we copy this and paste it. Not this. Yeah, here itself. And paste it in front of the latitude and longitude, like weighted latitude 0 is our weighted latitude and longitude 0, then weighted latitude and longitude 1, and weighted latitude and longitude 2. So basically what we had done is taken all these, where it is, yeah, all these latitudes and longitudes, and made one column for this, one for this, one for this. Okay, so this is the columns, and the values you will see that it is all the same. These are values are all those 6 values that we are having. Now we have the formula for to calculate the distance from the warehouses. So this is warehouse 0, the latitude and longitude we are using. So it is a big formula. Let me show you. Let's no, we don't need that. So this is a very big formula which we have taken from the internet to calculate the distance from the latitude and longitude from a specific location. The specific location is basically our latitude and longitude, which we have taken 0, and the distance we are calculating from our warehouse distance, which is this warehouse, this store distance, this store distance, not warehouse, store. This is one store. These are all the stores. Okay, so these are all the stores that we are having, and this is the weighted latitude and longitude of our store, which from and the distance from which we are calculating, and this is the distance. And you can see that the E2 I have E2 is, what is E2? Weighted latitude, then C2 is destination latitude, then E2 back is weighted latitude, then C2 back is destination latitude, then F2 is longitude and weighted longitude, sorry, and D2 is longitude. Okay, similarly, let's put escape. Similarly, we will copy this formula the across until the last. Okay, so we get the distance from each weighted distance from each warehouse like this, in this manner, which we want, and after that we do the same thing with our weighted latitude 1. Same formula with weighted latitude 1, all we get all the distance. Same formula with weighted latitude 2, we get all the distance. Then what we do is calculate the minimum distance of all these three distance. These are all the three distance which we are having. So and we call it as a weighted distance. So we use the minimum formula from this to this, which is whichever is minimum, we will get that. So we get the minimum here. And after getting the minimum, we use the F formula to calculate which store it is, that is the minimum warehouse, or sorry, which warehouse it is which is the most minimum. So in this case, let's say escape. In this case, the warehouse 0 was the smallest, was having the smallest distance. So let's see, the 0 is 48, yeah, and this is 100 and 1000 and 12, and this is 2000 and something. So the 48 is the minimum. So we calculate the minimum distance from each warehouse, and again we have done the sorting using the Control Shift and L, and let's see. Let's Control A and now see sort, custom sort. No, we haven't performed any here. Control Shift and L again. So we have calculated the whichever warehouse is the nearest from our store. All these warehouses we have calculated. Then we have calculated the store contribution. Like each store, what percentage of total it is contributing of the sum. Let me tell you. We are taking sum if 0th complete if this 0 is equal to O2, which is warehouse 0, then A to A. A to A meaning, let's go back to A. A is our demand. So then we are actually calculating by demand. So we take the demand divided by the sum of the total demand from the entire A column, the entire A column. Okay, so we are getting the demand wise of this first, then second, then third, then fourth. All the warehouses zeros I have taken one, grouped them or sorted them. Then we have 0, then 1, then 2. All these warehouses I have sorted them. Then I have taken the store contribution, which we have calculated through this formula, and this will tell the percentage of the total demand per warehouse, percentage of total demand per warehouse. Then we have done the cumulative sum of those contribution. So if we go down enough, we will see that we are getting 100% contribution. So it is working fine, and it is taking all the percentage and aggregating it to 100. Okay, so it is basically aggregating each and everything to 100, and in this way we can make out which warehouse or which how much distance we have demand from, what percentage demand we have from, like 50%. So this is 429. So this is how we calculate. Wait, let me tell you the formula of this. The cumulative average which we have done is here. Yeah, So if O3 this is equal to O2, if these twos are equal, then Q2, which is this, plus P3, which is this. So this plus this diagonally, or else P3. If not, then else P3. Basically this formula is telling us if these twos are equal, then what you do is aggregate, otherwise you don't. Because when we go down, let's go down, and when we come here, like these two are not equal, so this will not aggregate. Okay, so that is how we have done this. After doing all this, we go to the pivot table again and we create another pivot table. We select entire thing, we insert pivot table. After doing that, we go to, we made a pivot table per warehouse. Let's increase the size of it as much we can, and so that we can see more. Yeah, I don't think that we can increase it more. Okay, so what we have done, we have made the pivot table, we have kept the warehouses in the rows, and we have calculated the sum of the weighted distance, the sum of the weighted distance to both the weighted distance, no wait, the sum of the weighted distance, and the weighted distances, let me show you back. This is our weighted distance, which is the minimum distance. Okay, the minimum distance we have from the store is our weighted distance. Going back, so we have calculated the sum of it and average of it. Okay, and then we have the count of warehouses, number of warehouses that we are having, then sum of the total demand, the minimum and the maximum of the distance, the maximum distance and the minimum distance. The minimum distance is 48 and the maximum is 2000 something. Okay, so after that we just copy pasted it as values. We copied it and pasted it as values. Right click, paste it as values, this. Okay, and in this way we can perform further calculations. Otherwise we can't perform, otherwise it would have show some problems, which you already know, I think. Now what I have taken, I have calculated the percentage contribution again. This is the same thing, this is the percentage contribution per demand. So I have taken the total demand, grand total, which is, and calculated the percentage contribution. Then we have calculated the 30% demand. So we have gone, let's see, 30% demand of the warehouse 0. Go back. Then we see that the 30% demand, cumulative demand, we are getting at 210 kilometers. So we input the 210. Then the 50% demand we are getting at 430 kilometer. Let's cross check. Go down, go down, go down, go down. Wherever there is 50, this 430 kilometers approximately. Then we have 80% demand at 750 kilometers. Going back, this one 80% demand, 80. This is 80% demand we are getting at 750 kilometers. Okay, then similarly we calculate for the warehouse 1 as well. Let's go back, this gets to 100, and similarly we calculate for 30% for warehouse this, so 263 kilometers, which we input. Then 50% demand, let's go down, 50% demand, 334 kilometers. Go back, 335 kilometers approximately. Then 80% demand, 80. This is warehouse 1, the above was warehouse 0. Yeah, this is warehouse 0 and this is warehouse 1. So 80% demand, let's go, 80% demand, 740 kilometers approximately, 740 kilometers. Then similarly for the warehouse 2, go back, this will go to 100. Now warehouse 2 start from 0, and the 30 it is getting here only, 282 kilometers, Then 50% we are getting, going back, 610 kilometers, 610 kilometers approximately. Then 80% demand we are getting at 1100 kilometers. Go down, 83%, 1100 kilometers approximately I've taken. Okay, so this is how we have calculated that the demand, 30% demand that we are getting is in this kilometer range, and 50% in this kilometer range, and 80% demand in this kilometer range. So this helps us to understand that most of us demand is within the radius that we want. So in this way we actually try to calculate distance, latitude and longitude, which we calculated before. uh, the weighted latitude and longitude that we have calculated before, this basically tells us uh, per demand, weighted latitude and longitude per the store demand. And yeah, that is all in this project. Let me see, open that again. We have the cluster project, k-means clustering we have done, and the insights that we have taken from it, this project, is that we are able to calculate the minimum distance per store per demand. So we are able to calculate the minimum distance per store per demand and create a warehouse at those center points such that the logistic team could minimize their time of travel and the time of cost. So that if the travel time is reduced, the cost of the product will also be reduced. So this is our cluster project, and thank you for watching.